So the story of iGEM at Alverno actually began, I should say, back when I was applying to graduate school at Caltech and at a few other colleges around the country. And one of the amazing things about applying to graduate school is you get to go to a bunch of places and meet all the other people who are applying to graduate school, and you find out what they're doing and what's important to them and how they got to where they are. And one of the questions that came up a lot while I was interviewing was, oh, you're in bioengineering. What did your iGEM team do in undergraduate? What's this iGEM? I asked. We don't have one of these teams. So that was when I found out about iGEM. iGEM is an international synthetic biology competition. It's primarily made for undergrads, although about half the teams are graduate students. And these teams compete to make the most interesting, useful biological system that they can engineer. So we're talking about tools for biologists. We're talking about cells that can do something useful for us, like monitor the environment, monitor health problems in patients, anything that a cell can do, which is basically anything. We, as living beings, are testament to that. And they do it at the cutting edge of science. So iGEM, a little bit of funding to start up, and they're continuing to put on iGEM projects every summer. I thought that I was done with that when I came out to Caltech. I figured, oh, I'm in graduate school, I'll be busy. Well, no. So Monica Barsever came to us. I have to give a shout out to her because she's completely instrumental in everything that's happened so far here, in iGEM at least. She came to me in the lab and asked, hey, my students are interested in learning more about synthetic biology and maybe doing some synthetic biology themselves. Can you help? Sounded like, okay, I could go for an evening and talk about this. And I did, and that turned into a summer project. So now I'm happy to say at Alverno, we have successfully run an iGEM team over the summer, competing with undergrad teams and graduate school teams from across the world. And they are performing cutting edge research, right? They're in the thick of it, in the trenches, so to speak, doing science that we'll be using in the future. So why bioengineering first? Why is iGEM? You know, there are other similar kinds of competitions. Why is this one particularly important? Well, cells are, I think, and I think others in my field will say, they're the computers of the future, right? They are the silicon. They are tomorrow's laptops. Cells, again, we are all testament to this. They can do just about anything you can imagine if you can figure out how to make them do it. Right now we can't, right? This is somewhat in the future, but not that far in the future. So it's important that students growing up today understand how these things work, understand what they can do, and understand what it means to build something that's alive, and what the implications of that are for society, for technology, what you can do, the amazing things you can do, what are the risks involved, what are the things you have to be cognizant of. So that's why bioengineering, okay. Why this kind of competition? Why is this the way to teach it? Well, one of the important things about iGEM is that it is a scientific enterprise, but it's also an engineering discipline, right? This isn't a competition where you find out things, although you do, that's important. But the most important thing is to be able to build something new with everything that you learn. That's important if you want to go into engineering, of course, but I think it's also important to anybody who wants to make a difference in the world, because one of the key things we, particularly in an iGEM-like setting, is how to look at something very complex and intricate, a cell, and ask, how can I make this better?